Hello. In this video, I will do an SAT practice exercise on nonlinear functions, and these will technically be medium hard. Okay, so nonlinear functions, so that includes quadratics, what else? Quadratics, polynomials, exponentials, anything that's nonlinear. So I just want to note that when you're taking the neurodigital SAT, you can actually use Desmos for all the problems. So when I was doing these problems, some of them you could have just easily put in Desmo and find the answer. But I'm going to show you both ways because I think that would be better if I show you both ways and then you decide. Sometimes Desmo is faster and it's probably the easiest. But yeah, I'll show you. So question one says f of x equals x squared times x minus 35 cubed times x plus 84 cubed. That's definitely a polynomial. In the xy coordinate plane, there are exactly how many x-intercepts for the graph of the function given. So they want to know how much x-intercepts. They don't care about the multiplicity, so don't worry about the multiplicity. You might have a repeat of x-intercepts. That's okay. So how do you find the x-intercept? You set f of x to 0. Okay, and then if you set each equation to 0 and solve for x, you're going to get x equals 0, x equals 35, x equals negative 84, right? Now, it doesn't matter about the multiplicity. At x equals 0, it has a multiplicity of 2, 35 has a multiplicity of 3, and negative 84 has a multiplicity of 3. That's not what they're asking. They just want to know how much x-intercepts you have, and you have a total of 3 different x-intercepts. So it's going to be B. Okay, question two. The function f is defined by the given function equation. For what values of x does f of x reach its minimum? So if you want, they're asking you the minimum, so that's related to a vertex, right? So vertex. So they're asking you for, in a vertex, it's an x and a y coordinate, but they're only asking you for the x. They don't care about the y. So for what x value f of x reach its minimum, right? So if you want, you could easily just put this in Desmo. I'll show you. Go to Desmos, and this is question two. You just put that equation, okay? Let me zoom out. So they're asking you where it's the vertex, so it's either the lowest or the highest point, so it's this point, and it's the x value, so it is negative 2. Okay, now let's go back to the test. There's a way you could do it algebraically. Um, so what I would do is algebraically to find the x value of the vertex, just FOIL this out. It's going to be x squared plus 10x is negative 6x, negative 60. And that gives you x squared. 10x minus 6x is 7, 8, 9, 10. 4x minus 60. Okay. Now, how do you find the x value of the vertex? Use the equation x equals opposite of b over 2a. So go back to this equation. What is my a, my b, and my c value? My a is 1, my b is 4, c is negative 60. Okay, so the opposite of b, which is negative 4, over 2 times a, 2 times 1 is 2, which is negative 2. So it's going to be negative 2. Okay. So you could have easily put this in Desmo, or you could have just done some algebra, whatever you prefer. Question 3. Two quadratic functions are defined as f of x equals ax squared and g of x equals bx squared, where must be greater than 0, meaning it must be positive, and b must be less than 0. Or how many values of x can exist such that f of x equals g of x? So let's kind of test this out. Here we have two functions, right? F of x equals ax squared and g of x equals bx squared, right? In the first part, it says a where a is greater than 0, so that let's pick a value for a. What if a was 1? So that means it's going to be f of x equals x squared. And then where b is less than 0, so let's say b was negative 1. So that's g of x equals to negative x squared. Okay, so if you graph this, you'll see what that looks like. Um, f of x would look like this. G of x is concave down like that. So they're asking you how many intercepts you're going to have. One at the x value 0. So it's just going to be 1, b. Okay. Question 4. The function f of x equals 2 times 4 raised to the 2x is defined for all values of x. If g of x equals f of x plus 1, what is the function of g of x? So if g of x equals f of x plus 1, so this is like an input thing. This x plus 1 is like an input. And here's the function f of x, right? So g of x is going to be f of x plus 1. Well, first we got to find f of x plus 1. What is that going to be? So here's your f of x function. Wherever you've seen x, replace it with x plus 1. That's it. So it's going to be 2 times 4, and it's going to be raised 2 to the x plus 1. We get 2, 4. Boil out this 2. This is going to be 2x plus 2. So that is going to be letter B. Wait, no, not letter. I meant not letter B because ours is 2, 4. No, sorry, my bad. This plus 2 is not in the per power of 2. It's like a vertical shift. It's out. It's not in the parentheses. It's actually going to be letter, not B, letter D. G of x equals 2 of 4 raised to 2x plus 2. Okay. Question 5. The function f of x is an exponential function of the form f of x equals a times b raised to the x, where a and b are positive integers. If f of 2 equals 100 and f of 4 equals 2500, what is the value of b? So we're, we're dealing with an exponential function because it's in the form of y equals ab raised to the x. And they actually give us two coordinates. F of 2 equals 100 is the same thing as 2 comma 100. F of 4 of 2500 is the same thing as 4 comma 2500, right? So what we're going to do is plug in this. This is an x, this is a y, this is also an x, this is y. Let's plug in this point into this equation right here. So f of x is like your y value, so it's going to be 100 equals a times b, and my x is 2. Then what I would do is I'm going to isolate a, and you'll see why. I'm going to isolate a, so I have to get rid of this b squared by dividing both sides by b squared. So a equals 100 over b squared. Okay. Now go back to this point and plug that back into this equation. So it's going to be 2500 equals a times b raised to the x. My x is 4. Okay. Then what I could do is substitute my a with 100 over b squared divided by b4. b4 divided by b squared is b2, so it's 100 b2. Solve for b, so we're going to divide this by 100. You get the zeros cancel, so you're left with 25 equals to b squared. Solve for b by taking the square root of both sides, and you get b equals 5. Okay, that's simple. Okay. Question 6, the function h is defined by h of t equals at squared minus 3t plus 7, where h of negative 2 equals negative 3. What is the value of h of 2? So h of 2, 2 is like an input, and we got to figure out the output, right? So they give us a coordinate. H of negative 2 equals negative 3 is a coordinate. It's at negative 2, comma negative 3, right? So what we'll do is plug that point back into this equation. This is your x, this is your y. So it's going to be negative 3 equals a, and then t is like our x. So it's going to be negative 2 squared, negative 3 times negative 2 plus 7. Negative 2 squared is 4, that's 4a. Negative 3 times negative 2 is plus 6, plus 7. 6 plus 7 is 8, 9, 10, 11, 12, 13. Subtract 13 from both sides. That's negative 16 equals 4a. Divide this by 4. A is negative 16 over 4 is negative 4. Okay, so my h of t is going to be, my a is negative 4, so it's going to be negative 4t squared minus 3t plus 7. Okay, now we can find h of 2. So where we see 2, plug in 2. Okay, and then when you put it all together, 2 squared is 4. 2 squared is 4 times by negative 8 is negative 32 minus 6 plus 7. And you get negative 15 is my final answer. Okay, so that wasn't too bad, right? Okay, I guess we can end score by, I think I already did this one, so we should get 100. Good. Okay, so there's two more of these, and then let's do this one. Okay, question 1. The height of the rock being thrown off a cliff, it can be modeled by the function h of t equals negative 9.8 t squared plus 49 t plus 58.8, where t is the number of seconds that passes after the rock is thrown. After how many seconds will the rock hit the ground? Okay, so did you know this is if you want to graph it, our time is our x, and then our height is our y, right? We're gonna graph it like this. it would be, and then height. Okay. So if you graph it, this, I know it has a y-intercept of 58.8, so it's going to curve like this. And what you're doing is trying to find the x-intercept. So you could do it, on the SAT, you have Desmo, so you don't, how you could just plug that in back to Desmo. So how so is you just plug in that equation, y equals negative 9.8 t squared. So how do you do the square? Oh, click here, and then the square plus t. Okay, if I zoom out, um, they want to know the x-intercept. So it's this one, 6 and -1. But you can eliminate -1 because you can't go in time. So your answer should be 6. So at 6 seconds, that's when it would hit the ground. Now, if you want to do it the algebraic way, what you could do is set h to find the x-intercept. You set y to 0. Solve for t. So what you could do is divide both sides by negative 9.8. So you get 0 equals t squared. And then 49 divided by negative 9.8 is -5. And it's -6. Okay. So if I factor this out, it's going to be t. Well, two numbers multiply -6 and 1 added gives -5, 6 and 1. I'm going to use -6 and +1. So when you solve for t, you're going to get 6 and -1. So obviously you can't use -1 because we can't go back in time. So your answer shall be B. Okay. Question 2, given the function f of x squared minus 4x, which of the following is f of 2x? So this one's not too bad. It's like an input-output thing. So 2x is your input. We got to figure out our output. Okay, so wherever you see an x, plug in 2x. Wherever you see an x, plug in 2x. So that's going to be 2x squared minus 4 times 2x. 2x squared is 4x squared times 3. Wait, 2x squared is 4x squared. 10 by 3, that's 12x squared minus 8x. So it's B. Okay. Question 3. Okay, so this one I kind of got wrong at the first time. So function f of x is a quadratic function such that f of x plus 5 equals 0 yields exactly one real solution. Which of the following could be f of x? So how do you know if if a quadratic has one solution? That means it only crosses the x-axis once. So this would be twice, right? One real solution would be something like this. Okay. So be careful. There's a plus 5 here, and they're asking you what should f of x is. So you have to add that plus 5. So you could literally test each one and put it in Desmo and figure out if it touches the x-axis once. That would be correct. What you could also do is figure out the discriminant rule. So the discriminant rule is b squared minus 4ac. And if it gives you 0, that's how you know you have one x-intercept or one solution. Okay, so let's try out the first one. So be careful, it's f of x plus 5. So this whole thing is just f of x. So it's going to be x squared plus 10x plus 20 and then plus 5. So when you do that, you get x squared plus 10x plus 25. Okay. I mean, if now you could put this in Desmo if it crosses the x axis once, that's the one. But you can also use the discriminant rule. So b squared minus 4ac. And if it gives you a 0, that means that you have one real solution. So let's do that real quick. So it's my a, b, and c. My a is 1, my b is 10, and my c is 25, right? So b squared is going to be 10 squared minus 4 times a is 1, and c is 25. So 10 squared is 100. Negative 4 times 1 is 25. Is negative 100, or negative, yeah, gives you 0. So that yields 0. So this is the one. This is the correct answer. So when I first did this one, I thought it was this one. But keep in mind, this is just f of x, so you have to add that plus 5. And then this changes it. So that's why this one doesn't work. Okay, so be careful with these. Just make sure you read the questions carefully. Question 4. The population of shellfish along Kirby Coast is 2,000. In the year 2000 is 3,000. After 1 year, the population of shellfish increased to 3,600. If it's predicted the population will increase at an exponential rate, which of the following function will predict the population of shellfish SFT along the Kirby Coast T years after 2000? So when I hear the word exponential, that is a big clue. I mean, if you look at all the choices, it's definitely exponential, but when you're dealing with exponential, it's the form of y equals a times b raised to the x, right? And we got to figure out our a and our b. Do we have our a? We do, kind of. A is your initial value. So in the year 2000, it's 3,000. In the year 2000, it's 3,000. Please do not write at the coordinate. So you know your x is your time and your y is your shellfish. Do not write x is 2,000 and y is 3,000. No, 2,000 is your starting point. So it's really 0, 3,000. Okay. So don't, yeah. So that means if you plug in this point, that gives us our a value. So that means our a value is 3,000. Okay. Now, how do you find B? So they actually give you another point. It says after 1 year, the population shellfish increase to 3,600. Do not put 2001, 3,600. It's actually going to be 1, 3,600. Okay. So this is your X, this is your Y. And then replace my Y with 3,600. Replace my X with 1. So that's going to be 3,000 B plus 3,600. Solve for B by dividing both sides by 3,000. Okay. So my B is going to be, because you can use Desmos, it's going to be 3,600 divided by 3,000, which is 1.2. So my A is 3,000, my B is 1.2, so my answer is B. Okay, the function g of x is defined for all values of x. What is the maximum value of the function? So what is the maximum value? So whenever you hear the word max or min, it's always the y value of the vertex. Okay, so because you can use Desmo as in the digital SAT, what I would do is just plug that back in and then look. So if I plug in y equals, see, their vertex is the lowest or the highest point, so it's right here, and it looks like your max is 49. Okay, so you could have just looked at that and figure out it's 49. Now, if you want to do it the algebraic way, one way is to find the y value of the vertex. You must find the x value of the vertex. So what I would do is first FOIL this out. So it's going to be x squared negative 9x. 5 times x is 5x. 5 times negative 9 is negative 45. X squared. Negative 5 plus 5, negative 9 plus 5 is negative 4x. And then distribute that minus. So that's negative x squared plus 4x plus 45. Okay. Now, to find the x value of the vertex, you use opposite b over 2a. So my a is 1, my b is 4, and my c is 45. So opposite b is negative 4 over 2 times 1, which is negative 4 over 2, which is negative 2. Now to find the y value, you plug in negative 2 back into this function. It's going to be negative 2 plus 5, negative 2 minus 9. Negative 2 plus 5 is 3. Negative 2 minus 9 is 10, 11, negative 11. Did I do this right? 2a. Oh, my a is negative 1. That's why. So that's going to be positive 2. So it's actually positive 2, positive 2, positive 2. So this would be 5 plus 2 is, so 5 plus 2 is 7. 2 minus 9 is negative 7. That is positive 49. Okay. Okay. Let's do, I think there one more problem like this. Yeah, we got it all. Okay, so let's see here. The third one. Okay, let's do this part. And then this will be the end, or the end of the video. Okay, so let's start with question one. In the quadratic function, g of negative 2 equals 40, g of 0 equals 7.5, g of 2 equals negative 17. Write the equation that defines g. So I really don't know how I would put this in Desmo. I really don't. So I'll just show you the algebraic way. So what is an equation of a quadratic? So quadratic is a form of y equals ax squared plus bx plus c, right? And what they give us is three coordinates, negative 2 comma 40, 0 comma 7.5, and 2 comma negative 17, right? Okay. So what I'm going to do is plug in these points. I'm going to start with this point because I have a 0 somewhere. So that's good. That means something cancels. So if I plug in that point, so my y is 7.5, my 0 is x. When I put it all together, you get c equals 7.5. So I'm going to box it. Unfortunately, they all have 7.5 as your c, so we can't eliminate. So our equation is going to be y equals ax squared plus bx, and my c is a 7.5. Okay, so all I got to do is find my a and our b. So the next thing what you're going to do is plug in another point. So if I plug in this point, that means my y is 40, my x is negative 2 plus 7.5. Negative 2 squared is 4a, b times negative 2 is negative 2b plus 7.5. And what I'm going to do, and we're probably going to have to do a system of equation just to find a. So what I'm going to do is subtract 7.5. So 40 minus 7.5 is 32.5. Okay, I'm going to box it. And then what I'm going to do is plug in this point back into this equation right here. Okay, so it's going to be negative 17. Yeah, negative 17 equals to a is 2. So 2 squared plus b times 2. And my c is 7.5. It's going to be 2 squared is 4. That's 4a plus 2b plus 7.5. Subtract 7.5. And you get 17. 7.5 is negative 24.5, or a plus 2b. As you can see, the b's cancels, and then you're left with 4a plus 4a is 8a, and then 32.5 minus 24.5, I get 8. Solve for a by dividing both sides by 8. A equals 1. So that means it has to be b. You can do, you can also find the b by plugging in your, where can you, yeah, you can find b by substituting a into this equation, this one. But because you have a time limit, you can just pick the best one. So it's this one because your a is 1 and your c is 7.5. There's no other choice that has an a of 1 and 7.5. Okay. Okay. The quadratic function, the quadratic function has h of x equals a times 2x plus 3 times x minus 3, has a minimum value of negative 60.75. What is the value of a? So you can literally test each one and put it in Desmo, and if it gives you a minimum or a y value of a minimum of y value of negative 60.75, that's the one. You can also do a little bit of algebra. So if you want to do the algebra, right? Um, so we know that our min is negative 60.75. What you got to do is find the x-intercept. So how do you find the x-intercept? You set y to 0, and then you solve for x. Oh, then you would get rid of the a by dividing both sides by a. So you get 0 equals 2x plus 3, x minus 3. And then when you solve for x, you get negative 3 halves, and x equals 3. Okay. Then what you want to do is take the halfway point of these two values. So it's going to be, by the way, negative 3 halves is the same thing as negative 1.5. And you get 0.75. Okay. Then to find the a, all you got to do is 0.75 would be like your x. And then negative 60.75 will be your y. So it would be expressed as negative 60.75. And then wherever you see an a, plug in 0.75. So it's going to be 2 times 0.75 plus 3 times 0.75 minus 3, right? And when you do the work, you're going to get um, negative 1, negative 0.10.125a equals negative 60.75. Divide this by negative 10.125, and you get a equals 6. So that's how you do that. So yeah, you could or you could just test each one, put in Desmo. If it gives you a y, a lowest y value of negative 60.75, that's the one. Okay, question 3. So question 3, for a quadratic function k of x, you have a coordinate k of 4 equals 9.3, a coordinate of k of 5 equals negative 7.1, and another coordinate of k of 6 equals negative 4.6. Which of the following is true about the function? So I would not, I would just plot these points. I wouldn't try to find the equation. You don't have to find the equation. So you have a point at 4 comma 9.3, another one at 5 comma negative 7.1, and then another point at 6 comma negative 4.6. Okay, so if you kind of plot it, this is going to be 2, 2, 4. Okay, so if I plotted 5 commas negative 7.1 would be right about here. 6 comma negative 4.6 is, oh, and then 4 comma 9.3 is right about here. So if you connect the dots, and this is a quadratic, so this is obviously going to go up. It looks like you have a solution. This is your solution, a point on the graph. It looks like you have a solution as at the x value somewhere between 5. So I think it's going to be B. Because a solution to k of x between the x value 4 and 5, right? That's true. You have a solution here. The x coordinate is between 4 and 5. So that's why I think it's B. Okay, question 4. Question 4 says, a triangle has a base that is 6 feet longer than twice the height. The function a models the area of the triangle in square feet where h is the height of the triangle. Which equation defines the equation a of h? So pretend you have a triangle, and they're saying that the base is 6 feet longer than twice the height. So how can I write an expression? It would be 2 times h plus 6. And we got to find the area of this triangle. So what is the area of a triangle? It's basically base times height over 2. So my base is 2h plus 6. And then my height is just h, and then all over 2. Okay, clean this up. 2h times h is 2h squared. 6 times h is 6h all over 2. Clean this up. If you divide each term by 2, this is going to be h squared. And then this h, 6 divided by 2 is 3h. And then you made factor out an h, so this is going to be h plus 3. So letter B. Oh, sorry, did you need that? Okay. So yeah, that would be letter B. Okay, last one. Question 5, the given equation has exactly one solution. What is the value of C? So we have this equation 36x squared plus 60x plus C. How do we know if a quadratic has one solution? You use the discriminant rule, and more specifically is it's b squared minus 4ac. And if it gives you an outcome of 0, that's how you know you have one solution. So let's try to do that. What's my A, B, and my C is just C. So my A is going to be 36. My B is going to be 60, and my C is just going to be C. So put that in the formula. So B squared is 36 squared minus 4 times A is 36, C is C. And we set that to 0. So what is 36 squared? Uh, my bad, my mistake. It's B squared minus 4AC, so it's going to be 60 squared minus 4 times A, and C is C. Set that to 0. Okay, that's much better. So 60 squared is 3600. Negative 4 times 36 is negative 144. C equals to 0. And then I can add 144C. So I get 3600 equals to 144C. Solve for C, so you're going to divide this by 144. 144, you get C equals to 25. Okay, so your answer for question 5 is 25. Okay, and then score, let's see what I get. Okay, we got it all right. Okay, so I'm going to stop here. I'm going to end the video.